All right. So we just saw a presentation on a very new library, and this is a talk about a very old library. So who's heard of LeakCanary before? Wow, cool. I hope you love it. Maybe not, and we'll talk about why not. But LeakCanary was, so my name is Pierre-Yves or PY. I work at Square, and I'm the main maintainer of LeakCanary. So in 2015, I made the first release. And the summary, you probably already know that. The summary is that sometimes you have objects that cannot be garbage collected. And when those objects, because of memory leaks, and those objects accumulate, and that leads to out-of-memory errors. And LeakCanary, what it does is just keep weak references to these objects that we know, some objects that we know should be garbage collected, such as activities after on destroy. If they're not garbage collected, it actually creates a heap dump, which is a copy of the memory, and parses it and finds why it's not leaking, why it's leaking. All right, so that's a quick summary. So when we did it in 2015, it helped. Like, I think we reduced the out-of-memory error rate by 90%. It was insane because we fixed our top leaks. And then we hired more engineers. We had more code and more code and more code, and it became really hard. And then we had RxJava. It became really hard to understand memory leaks. And LeakCanary 1 had a few shortcomings. So number one was one of them was the UI, and trying to understand what this is about. Like, we tried to make it easy to understand, but it was still kind of confusing. Like, what's all this about? What's this string on the side? Not necessarily easy. Even with the color, it's kind of confusing. The other thing that probably frustrates a lot of people is that when LeakCanary finds one leak, it does a heap dump, which freezes the UI, and then it calculates things and gives you a notification. And when you have a few leaks, or when you're using Android, I think it was P, where there's a leak in the framework, then it's constantly dumping the heap, saying, I found a leak, I found a leak, I found a leak, and you can't use the app, you can't develop. I think someone was just telling me a few minutes ago that they installed LeakCanary, and later they came back, there was no leaks anymore, but I realized someone had commented out LeakCanary. So, yeah, that happens, right? And that makes sense because it was frustrating. So it was freezing all the time. That was really annoying, especially when it's a leak in the Android framework and there's pretty much nothing you can do about it, aside from asking your users to move to the next version. So some of the other problems were like the setup could have been easier. There were like a few things with debug implementation, release implementation. You had to do a whole like check for the process because LeakCanary runs in a different process. Not great. And then the configuration was also pretty hard. Like, this is all the code you have to write to be able to turn it on and off at runtime. And finally, maybe the most important, the logo wasn't great. Some people love it. Some people maybe hate it, probably because it's freezing all the time. This was like 5 minutes of my time, like from Google Image and doing some stuff in Photoshop. And then Romagui, his main contribution to LeakCanary was making a vector version of this. So LeakCanary 2. What's new in LeakCanary? So obviously, the first thing you probably noticed, a new logo. That's very important. Woo! So you saw Joe introducing the meetup. His wife made the logo. She's a designer at Square. It's an amazing logo. It does not look like the Twitter logo. I disagree completely. The wings are on the other side, and it's dead. It's a dead bird. So come on. I love the logo though. A few other internal changes. We converted the entirety of the code to Kotlin. We updated to Android X. So overall, a lot of changes, but that's not very interesting. So the first interesting change is that instead of dumping the heap every time there's one leak or one retained instance found, instead LeakCanary waits. It waits for a threshold, which is at 5 right now. And when it gets to 5 retained instances, then it dumps the heap, and it will actually analyze and find all of the leaks, all of those 5 leaks. When you're in the foreground. If the app is in the background, then it does it on every leak because it's not really annoying to you. But if it's in the foreground, it means It means that leaks like the ones that are in Android, they're usually replacing themselves. So they're gonna maybe now you have room for 3 leaks before it does the memory leak. So you'll find your own leaks. I want to thank Ty for the idea of showing that information as a notification, which means that you can at any point say, well, all right, I want to see what's there, and click on it. And now it does the heap dump and tell you what it's found. A few other changes, like if you let it go and didn't delete leaks, it would take forever to open the list of leaks because you had hundreds of files and that was very slow. Now it's all in SQLite, so it's way faster. But finding more instances, it was already pretty slow, and having more instances to find made it slower. That was kind of a problem. So we'll talk about that in a bit. One of the most interesting thing with LeakCanary 2 is the change is in how we displayed information. I'll zoom in a minute so that, because you can all read, right? Like it's fine, you have laser eyes. So this is the new leak trace format. At the high level, it's interesting to notice it goes from the top to the bottom, right? And this is a chain of references. And every entry is an instance. So you have the class name of that instance, and then you have some extra information. I'll get into that. So we're looking at the root here. And already you'll notice there's something interesting. Under it, it says leaking no. So LeakCanary is now able to tell you, or to make a guess about whether an instance is leaking or not. So for example, here, it's saying, well, this is a class. A class is never leaking. This class, though, has a field, a static field called input-method-manager.sinstance, right? But we know that the class itself is not leaking, but it has a static field to another object. And you'll see the details every time. So it's this is a GC root, so it's probably not leaking, and the class is never leaking. And we move on to the next thing. And we can see that the second one is not leaking as well. Why? Because the third one is not leaking. So the idea is if I'm holding something that's not leaking, then myself I'm not leaking. And we'll get into why this is not leaking. So the forced, so input method manager has a mnext serve view, which points to a forced keyboard edit text, which is not leaking because the next one is not leaking, but also because this is a view and the view is attached. When a view is attached, it's not leaking. How do we know the view is attached? So now you have extra information in LeakCanary that tells you m attached info is not null, so the view is attached. Oh, and by the way, it has a parent, and by the way, its ID is r.id.enter store edit text, which helps a lot with understanding where the leak is happening. And the window attached count is 1. And then it points to the next instance, which is a fragment. So that fragment is not leaking. Why? Because it has a fragment manager field, which is not null. And if you dive into the source code of fragments, you'll realize that when fragments basically are detached, they have mfragment manager set to null. And let's skip over and look at the last one. And so the last one is constraint layout. And it's saying constraint layout is leaking, yes, because we passed it to LeakCanary. And if we did that, it's because we knew it was detached and it needed to be garbage collected. Now, something interesting is happening here. There's like little wiggles. What's that about? So this is supposed to emulate kind of like the red error in your IDE. It's kind of trying to do fun stuff with text. But the key idea is we know that this fragment is not leaking. We know that this constraint layout is leaking. So the problem is somewhere in the middle. And essentially, it's one of these two references. And so that's what this is doing. So this is a big change in LeakCanary because what it does is we're trying to guess the state of things and determine if it's leaking or not. And then we can say the leak is like one of these 2 or 3 things. So it helps a lot. Now, the other thing that this gives us is you'll find that sometimes one specific bug in your code is creating a leak, but it's surfacing in many different ways. So you get different leak traces, like this is different from this, which is different from this. However, LeakCanary has been able to identify the likely causes, which I showed you as the little wiggles, and they're here in this case. And if they have the same causes, it means the leak is in the same place. And if the leak is in the same place, it's the same leak. So this should all be grouped together. And that's what LeakCanary does now. It basically, instead of a huge list of things, it just has as many groups of leaks and just shows, OK, this one has, you've had 11 leaks of that one and 12 of that one. So Oh yeah. Yeah, that's exciting. No more huge list. It also means you can safely ignore the AOSP ones. What was the most common issue with LeakCanary, aside from the logo being ugly? Um, the most common one, it's kind of meta, was out of memory error. So LeakCanary would crash trying to analyze the memory because it was parsing an entire memory heap dump, which is a lot of information. And the code that was doing that was actually extracted from Android Studio. It's the same thing that you run when you run the profiler in Android Studio. So I extracted that and turned that into a library. But it's made to run in Android. You know, Android Studio loves using all of your memory. You know why? But it doesn't have the same constraints. I shouldn't throw shade like that. It doesn't have the same constraints as a mobile app. And so that was kind of annoying. It would use 200 megs, 300 megs just to analyze a heap dump. So there was only one solution. Write a new heap dump parser, which we've talked about. John probably remembers. We've talked about that for years. There's been experiments. But it's scary, and eventually we did it. So the key idea was, let's write a new heap dump parser, but instead of loading the entire graph of objects in memory, it's going to scan the file, create an index, and then navigate through the file as we try to navigate through the graph, and read just what we need from the specific position in the file, and then not keep anything else in memory. And so by doing that, it reduces the memory by a lot. How much exactly? So that was interesting. I profiled the thing. It might not be the most professional like comparison of performance stuff, but it kind of gave me a good idea. So here we're looking at what we were doing before with perflib, and that was, so you could see that's one analysis, and you could see it went up by about 140 megs, and it took about 35 seconds. And then we did it with the new one on the same heap dump, and that's what it looks like. And so that's about 10 times less memory and 6 times faster. So that's like a big change. So what that means is that we're able to analyze much faster, and we're not going to crash your app trying to analyze the heap dump. There's a lot of optimizations for this, but eventually it was a pretty good result. I was pretty happy with that. So that new parser is a game changer. It means that LeakCanary does not need to run in a separate process anymore because it doesn't use that much memory. It also means that we don't need all of that complicated setup. So all of this is just gone. Instead, what we have is just add the dependency. No code, no setup. You add the dependency, LeakCanary is running in your app. That's it. That's not it for the talk. That's it for the dependency. A few more things that I wanted to mention. You may not know that LeakCanary can run in instrumentation test, and in fact, we do that at Square. And essentially what it does, it's a different mode for LeakCanary, and it's a special artifact, but it'll essentially wait for the end of the UI test. It'll capture leaking references, but it won't do anything until the end of the UI test, and then it looks at the memory. That way your UI test is not disturbed. It waits for it, and it fails the test, which we would see here if there's a leak. And so you get this nice like test report that has the leak trace, as we saw earlier. Another interesting new feature is the ability to import HProf files. This is more for me. When people report bugs, I can just take their HProf and read it and understand what happened. And if there was a bug in LeakCanary, I can fix it and test that it's reproducing. Another thing that's recent is actually another of John's idea is HProf writer. That's not something you're going to use, but essentially the unit tests are now able to write their own HProf files, and basically there's a lot more test coverage. So obviously, hopefully, everything's better. Someone just liked this today, and I just thought, it's not someone from Square, and I didn't ask for anything. And I was like, cool, the new LeakCanary alpha is great. Blah, blah, I feel productive. It's great. I'm delighted to see LeakCanary. It's like, oh, wow, it's a big change. No more commenting it out, you know? So that's pretty much it. So if you want to try it out, this is what you do. You'll notice it's still an alpha. It's alpha 2, so it's like super stable. The big thing with the alpha is that the APIs have changed a lot, but I want to keep changing them. And so until we iterate quite a bit, I'm not ready to go to beta. And also, I want to keep testing it with our internal applications, make it better for everybody. That being said, it's a dev tool, so you don't really care if you're using alpha or beta. You're not shipping this to production, I hope. And there is a migration page on the GitHub, so you can look at that and see. Yeah, I'll be there for questions later.